So hello everyone, in this short video we are going to perform an example on first derivative test for local extrema. So we are given a function, as you can see here, fx equal to x1 over 3 times x minus 4, and it has been expanded for you. We have x to the power 4 over 3 minus 4x1 over 3 to ease the process of differentiation, but of course can also perform the differentiation from this one, right, using the product rule. So there are a couple of things that we need to do. First, we want to identify the open interval, okay, whether it is increasing or decreasing, and then we want to find the function's local and absolute extreme values. Right, so the first thing that we need to do is to find the derivative and then find the critical points. So this is pretty straightforward. We have f prime x equal to, okay, for the first term here we have 4 over 3 x times 4 over 3 minus 1, then we have 1 over 3 minus, we have 4 there, times 1 over 3, so there is also 4 over 3, then we have x, 1 over 3 minus 1, that will give us negative 2 over 3. Alright, and of course we can further simplify this. Okay, means that we can bring out 4 over 3 from both terms there, so we have 4 over 3. Then I can also bring out x, negative 2 over 3 times x minus 1, and this is actually, okay, you can do some rearrangement to have it in this form. 4x minus 1 over 3x to the power 2 over 3, because here we have negative 2 over 3, and it's pretty obvious. We have, okay, the function is 0 when x equal to 1, okay, 0 at x equal to 1, okay, this f prime x 0 when x equal to 1, and it is undefined when the denominator is 0, that is when x equal to 0. So we have two critical points, and notice that we have no endpoints in the domain, so only these two places, okay, that will be considered in our timeline. That is, the first one is x equal to 0, and the second one is x equal to 1, and then we need to find the sign of f prime. So you can choose any value that is less than 0, and maybe you can choose x equal to negative 1, or maybe you can even choose x equal to negative 100, negative 1000, negative 3, or whatsoever. So you will find out that the sign of f prime for this first interval is negative. Alright, so second one here, between 0 and 1, you'll find that it is also negative. Okay, you can choose any value, 0.5, 0.6. Okay, any single value that you choose here will give you, okay, f prime, the sign will be negative. And for this third interval, x greater than 1, you can choose any value as well, and you find out that the sign is positive. So here we have our function to be decreasing, here also decreasing, and here is increasing. Alright, so using corollary 3, that is the consequence of the mean value theorem, we know that f, okay, we have to make a conclusion that f decreases on negative infinity to 0, decreases on 0 to 1, and increases when we have the interval 1 to infinity. And the first derivative test for local extrema, of course, tell us that f does not have an extreme value at x equal to 0. Okay, mean that it does not have extremum, either minimum or maximum. But here, because it changes sign for the second part here, when x equal to 1, first we have it decreasing, sorry, you can imagine that shape is here, then we have increasing here, and since at this point, okay, because it is continuous everywhere, so we know that we have a local minimum at x equal to 1. Okay, from the fact that f prime changes from negative to positive. So the value of the local minimum, okay, you can find f1. So f1 here, okay, you can plug in the values and you will get it is actually equal to negative 3. Okay, this is also an absolute minimum value since f is decreasing from negative infinity to 1 and increasing on 1 to infinity for the whole domain, can say so, right? So we can also notice that the limit as x approaching 0 for f prime x is equal to negative infinity. So the graph of f has a vertical tangent at the origin. So this is the figure of our function just now. Okay, so you see here we have a vertical tangent when x equal to 0 when x approaching 0. Alright, and then we also have the absolute minimum, okay, when x equal to 1, and the function value here is negative 3.